Chapter 2.6 is going to be ratios, proportions, and percents. So starting with ratios first, a ratio is just a comparison between two quantities using a quotient. So it's just a number divided by another number. There's going to be three different ways we can write ratios. So I'm sure we're all used to the last way how to write a ratio because it's just division, A over B. Another way to write it is using a colon. So that's A to B. And then the other way is literally what I just said, A to B. So these all mean the same exact thing. So let's do a little example here. So let's write a ratio for each word phrase and express the fractions in lowest terms if we can. So for the first one, we have 5 hours to 3 hours. So they do have to be the same units. So these are the same units, they're both hours. So as a ratio here, we have a couple options. So I'm going to use the fraction one. So 5 to 3, that's going to be 5 over 3. So pretty simple. The hours cancel. We have 5 hours over 3 hours. Hours over hours, they cancel, and we're done. So that has to happen most of the time for these ratios. And for the next one, we have 6 hours to 3 days. So this time we need to get either hours into days units or days into hours. It's going to be a little bit cleaner if we rewrite 3 days into hours. So there are 24 hours in one day. So that means we're just going to multiply 24 hours times 3. So in 3 days, that is equivalent to 72 hours. So now we're comparing 6 hours to 72 hours, which is going to be 6 over 72. Hours over hours cancel each other. In lowest terms here, they both have a common factor of 6. So we get 1 over 12, or 1 to 12. Okay, so that's ratios. Pretty simple, probably. So next, for proportions, getting a little bit more complicated. So proportions, we know that a ratio is used to compare two numbers. A proportion is going to say that two ratios are equal. So we're going to have one ratio equals another ratio. That is a proportion. So for example, let's say we had 15 over 20. That's a ratio, right? We know that this is equal to 3 over 4 because we can simplify it. So now this is a proportion. We have a ratio equals another ratio. So now it's a proportion. So in general here, a proportion is just going to look like what I have right down here. We have A over B equals C over D. And A, B, and C, and D are just going to be called the terms of the proportion. So something that's pretty useful when we're dealing with proportions is what we call cross multiplying. So technically, this is nothing new. It's just another way of thinking about it and some other terminology. So when we're dealing with a proportion A over B equals C over D, what we can do is we can multiply both sides by the least common denominator, which in this case would be B times D, just multiplying those denominators together. So what we would end up with is we would end up with AD equals BC. So starting with the proportion A over B equals C over D, we get AD equals BC. Okay, so when we think of this as cross-multiplying, so trying to make this a little bit more sense now, what we can do here with this proportion A over B equals C over D, we're going to multiply this denominator up here, and then we're going to multiply this denominator up here. So you can see why it's called cross-multiplying now. Technically, we're just multiplying both sides by B and both sides by D. But what we end up getting is A times D equals b times c. Sorry, I shouldn't have put an equal sign there. Just put a little arrow. Okay, so that's all cross multiplying is. It's pretty simple. So let's do some examples so we don't have to work with generic letters so you can actually see numbers in action. So let's decide whether each proportion is true or false by cross multiplying. So if we want to know if 3/4 is equal to 15 over 20, obviously we can just reduce the right side of the equation, reduce that fraction and make it equal. But let's do it with cross multiplying. So cross multiplying means we're going to take that denominator, multiply it up there, this denominator, multiply it up there. So this is going to be 3 times 20 equals 4 times 15. And we're checking to see if these are equal. So this is going to give us 60 equals 60. So that means that's obviously correct. 60 does equal 60. So this proportion is true. So for the next one, for B, we have 6 over 7 equals 30 over 32. So maybe at first glance, you can't necessarily tell if that's going to be true or not. So let's cross multiply. So that denominator over there, this one up here. So it's going to be 6 times 32. And we want to see if that's equal to 7 over 30. So 6 times 32. 6 times 32 is going to be 192. And 7 times 30 is going to be 210. So that's obviously not true. 192 does not equal 210. So this original proportion is false. Okay, so this cross multiplying is going to come in handy when we're trying to solve equations. So let's say we have the equation 5 over 9 equals x over 63. So technically what we could do here, and which would be a little bit shorter actually, is if we multiplied both sides by 63. But let's think about this as cross multiplying. So cross multiplying, it's going to be 5 times 63 equals 9 times x. So denominators to other numerators. Okay, so 5 times 63 is going to give us 315. And then we have to divide both sides by 9. So when we divide both sides by 9, we get x equals 315 over 9, which ends up giving us 35. So that means 5 over 9 equals 35 over 63. Keep in mind that cross multiplying is only a thing when we're dealing with an equal sign. We're talking about crossing through the equal sign, not when we're multiplying fractions. Okay, make it a little bit harder here. So we have m minus 2 over 5 equals m plus 1 over 3. So we're going to multiply denominators to the opposite side numerators. So we're going to get 3 times m minus 2 equals 5 times m plus 1. So now we're going to solve this for m. So we have to distribute on both sides. So we get 3m minus 6 equals 5m plus 5. Let's get all of the m's on one side. So I would usually get the m's on the right-hand side because it would be positive, but just to do it a little bit differently and make it a little bit harder, I'll get the m's on the left, which means they'll be negative. So it's going to be negative 2m minus 6 equals 5. Going to add 6 to both sides. Cancels on the left. We get negative 2m equals 11. Divide both sides by negative 2. So we're going to get m equals 11 over negative 2, or just negative 11 over 2. So it's a little bit messy, but that is okay. Okay, so now let's actually do some proportion examples that are actually word problems and something that actually kind of comes up in everyday life here. So after Leanne pumped 5 gallons of gasoline, the display showing the price read $18.10. When she finished pumping the gas, the price read $52.49. We want to know how many gallons did she pump. Okay, so 5 gallons cost $18.10. And then X gallons cost $52.49. So what I'm going to do is price per gallon equals price per gallon. So I'm going to say $8.10 over 5 equals $52.49 over X, because that's what we're looking for. How many gallons did she pump? So really important, we have price in the numerator, and then we have gallons in the denominator. They have to be that way on both sides of the equation. So they're both price per gallons. So let's solve this by cross multiplying. So it's going to be this one to that side, this one to that numerator. We're going to get 18.1 x equals 5 times 52.49. And obviously I just dropped the dollar sign here, which is fine. Okay, so for the 5 times 52.49, the right-hand side, we end up with 262.4.45. And now to get x by itself, we need to divide both sides by 18.1. Okay, so that gives us x alone on the left. So 262.45 divided by 18.1 gives us 14.5. So this is in gallons. So let's see if it makes sense. So we said our answer is 14.5 gallons. So 5 gallons was $18.10. 14.5 gallons cost $52.49. So sure, makes sense. We didn't get some crazy number. It seems reasonable. Okay, so for the next thing, we're going to do a little bit with percents. So a percent is a ratio where the second number is always 100. So percent literally means for every 100. The per means for every. And the cent means 100. So for every 100 means something divided by 100. So you can kind of remember that because when you're thinking about miles per hour, that's miles for every hour driven, for if you're in a car. And then cent, meaning 100, you can think of it as cents, as in money, as in change. There's 100 cents to a dollar. Or you can think of it as century. Century, there's 100 years to a century. Just a lot of different ways to remember that. Okay, so for example, we have 50%. So 50%, we can think of it as a ratio. We can think of it as 50 to 100. Or we can think of it as 50 over 100, or we can think of it as 0.5. So always going to be all these different ways of thinking about these. And for 27%, once again, that can be 27 to 100, or 27 for every 100, or 27 over 100, or 0.27. Okay, so we can set this up using a percent or a proportion. And it's going to be x% over 100%. So the way that we set this up is like this. The part over whole of something is going to equal x% over 100%. So that just means that the x% would be the part, the 100% is the whole. Okay, so let's do a couple examples here. So we want to know what is 15% of 600. So let's use that ratio. So it's going to be part over whole equals x% over 100%. So the part is what we're looking for. We're looking for the 15%, so I'm going to let that be x. So part over whole, x over 600, equals 15% over 100%. Okay, so I'm going to drop the percentages and when I write it down like this, when I'm solving it, because they cancel out, so they don't need to be there. So let's cross multiply. So we're going to get 100x. Put the little cross multiplying. So we're going to get 100x equals 15 times 600. So 15 times 600 will give us 9,000. So it's going to be 100x equals 9,000. Divide both sides by 100. That's going to give us, x is 9,000 over 100, so x is going to be 90 here. So 15% of 600 is 90. Okay, let's do a couple more. So we want to know 32% of what number is 64. So setting up this proportion again, I'll start with the percentages because it's a little bit easier. 32 over 100, obviously. So we want to know 30% of what. So of what is the whole? So that's what we're looking for down there, the denominator. So 64 is the part. So solving this, we need to cross multiply. So that's going to be 64 times 100 equals 32 times x. So that's going to be 6,400 equals 32x. Divide both sides by 32. Cancel. We get x equals 6,400 over 32, which is going to give us 200. So 32% of 200 is 64. Okay, I believe this is the last question. So the last one, 90 is what percent of 360? So we are looking for the percent. So we're looking for x. So x over 100, and it says 90 is what percent of 360? So 90 over 360 equals x over 100. So cross multiply. And we're going to get 90 times 100 equals 360 times x. That's going to be 9,000 equals 360x. And we're going to divide both sides by 360 to get x alone. So we get x equals 9,000 divided by 360, which is 25, which is 25%. Okay, so 90 is 25% of 360. Okay, so that is it for chapter 2.6. That was ratios, proportions, and percents.